Monostable multivibrator circuit shown in figure. The circuit consists of two transistors and n-pn transistor that consists of base, emitter and collector. Base of transistor 1 is coupled to transistor collector point through R1. Base of transistor 2 is coupled to collector of transistor 1 through C1 capacitor. RC1 and RC2 are collector resistance plus VCC supply over minus VB negative sources. That is monostable state. Mono means one stable state. Stable to unstable. Unstable to unstable triggering applied. First step we are stable state to going unstable state applied triggering pulse. Unstable to stable state no triggering pulse applied. Negative supply is minus VB is connected to base of transistor 1. So transistor 1 is off. VCE go to 0, T2 is on. Transistor 2 is Q2 is on. That is unstable state. Then is triggering pulse is applied in T1 of base using capacitor C2. T1 is transistor Q1 is on. VC is go to 0. So transistor Q2 off. Transistor Q1 is on, transistor Q2 is off. That is one stage. T1 is on, T2 is off. That is unstable state. Using charging circuit C1 and R1 charge is the base of T1. T1 goes to off and T2 goes to on. That is stable state. That is called monostable state. The circuit operation clearly seen in notes. Thank you. Power electronics. Good morning to all. Monostable multivibrator. It has one stable state. When a trigger is applied, the circuit changes from stable to quasi-stable state. After some time, it goes to original state. Q1 and Q2 are identical transistors. The two collector resistors are equal to RC. The collector of Q2 is coupled to the base of Q1 through R1. The collector of Q1 is coupled to the base of Q2 through C1. RC1 and minus VB are selected so that Q1 is off by reverse biasing edge. Q2 is on with the help of VCC and R. Q2 on and Q1 is off is the stable state. Positive triggering pulse is applied to the base of Q1 through C2. Q1 starts conducting. The collector voltage Q1 VC1 decreases. This is coupled to the base of Q2 through C1. But voltage across C1 cannot change immediately. So forward bias of Q2 decreases. Hence collector current of Q2 decreases. The collector voltage of Q2 increases. It is applied to the base of Q1. This further increases the base voltage of Q1. Q1 is driven to conduction and Q2 becomes off. This is the quasi-stable state. The circuit will remain in the state for a time period of T. During this state, C1 starts charging through the path VCC. RC1 and Q1 So the base voltage of Q2 increases. When this voltage reaches the cut-in voltage of Q2, then Q2 starts conducting. Due to the regenerative action, Q2 is turned on. The circuit returns back to a stable state. The time period T is equal to 0.69 or C. Monostable multivibrator waveform shown in figure. The circuit has single stable state. Mono means one, that is single stable state. Voltage versus time. Graph shown in figure. 0.2 volt small line, 5 volt large line. Get the steady state at 0.2 volt and 5 volt. 0.2 volt low, 5 volt high. Output changes from high to low state. Input is low. The circuit is contributed. The circuit transition is very nice. It's not depend upon the transistor. When triggering pulse input apply, output is obtained square waveform. That is 0.2 volts value. We obtain square waveform. 0 volts and minus VCC graph shown in figure. T2, T3 square waveform we obtained shown in notes.